This is red. So I was like, okay. So it's probably
All right. All right, everybody. We're going to bring it back in. Before we start, a couple of. Does anybody have any announcements to make?
Hello, everyone. My name's Evan. It's my first ever time coming to one of these meetings. I'm really enjoying it. I work for the Consumer Financial Protection Bureau here in DC. Little badge, so I actually. Anywho, they're looking for applicants for their 2015 Technology and Innovation Fellowships. They start in January, but applications are due in 2 weeks. And they're really, everything that CFPB does is centered around Python, and they're really looking for a few good developers. And so if you're interested, I have forms and information about it, so come find me, please. Thank you.
Anybody else?
Yeah, to follow that and kind of, sorry, I'm gonna borrow your thunder. I work with Navigate Consulting. My name is Patrick. And I need to be careful couching this in a room full of development-oriented people. My framework is much more ambiguous. We are interested in Python. We're interested in Python talent. We don't have a deep bench on our side, so I have nothing like what you have. So we don't have a clear path to onboarding. But if you want to come speak to me about opportunities in the consulting world, we do a lot of stuff with data analytics and text analytics and kind of, so it's definitely interesting stuff. But you know where the fits are, we still need to figure out. So that's my pitch.
Anybody else? All right. We'd like to thank the advisory board company for providing the space this evening. They've been very generous in their support of DC Python. All right. I'm going to pass it over.
Thank you, Daniel.
Is your microphone on?
Yeah. Guess it's not. Yeah, it is actually. My name is Lababidi. Thank you for having me. I work at Zoom. We are a social media analytics platform based in Western Virginia. I am the sole data scientist there, and one of the projects I work on is related to natural language processing and sentiment analysis. So today I'm basically presenting you some basics in natural language processing with Python. So to kind of give you the overview of what you can do with natural language with Python using natural language processing, there's a toolkit called NLTK. Okay. Well, this is actually NLTK trainer, but this toolkit basically is a good starting point for anything you want to do with natural language processing. So that can include tokenization. So let's say you have a sentence and you want to break that sentence apart in words. So you say, okay, take away all the spaces and that'll give you a word. But what about punctuation? Does a like doesn't has an apostrophe in it? So is that legal in to separate it or not? So a lot of these things are taken care of and they're explained in this book. So I'm not going to get into serious detail on that, but I wanted to give you a couple examples before I jump in. So a lot of times you want to analyze text. So I was trying to think of something to analyze, some sort of text. And I decided to work on a project related to this guy. He came up with this graph that basically says, these wrappers use, I don't know if you can see, it's 2,900 unique words. And that would be, I believe that's DMX. Yeah. So basically this guy did this awesome homework on analysis on all these rappers, all the way to Wu-Tang Clan and the RZA, the Roots. And they're over here comparatively with Moby Dick, with the amount of unique words they have in their lyrics. We got some people like Outkast over here and Redman from Wu-Tang as well, and so on. And so you see that there's a big cluster here. So what I kind of thought was, well, who are some of the famous rappers today? And I thought, well, Drake is a famous rapper currently. I actually don't listen to much rap. I just saw this and thought, who's famous? So I saw Drake, and he's kind of over here in the lower end.
Eminem, around 4,500.
Yeah, there he is. And there's Kanye, and then there's one dude named Wiz Khalifa. So I just kind of took these two guys who are pretty popular these days, along with the Jizza. The Jizza, he's over here. And he's probably one of the higher ones in this list. And I thought, is there a way I could use some sort of feature from their lyrics to determine if it is their lyrics? So the idea is to step back and go, if somebody gave me a piece of lyric or text that any of these three guys had written, can I determine where it came from? Because you can see that there's a discrepancy in the vocabulary. So I'm not going to really get into the vocabulary aspect. I'm not going to look at the actual words. And by the way, interrupt me with any questions. You know, I like that flow much better than, you forget your question at the end. You sit here at the end having 10 questions in a row. So what I did is there's this terrific site called RapGenius where you can download, or not download, but you can view all the lyrics to all these songs. So this down here, I don't know if anyone's familiar with Chrome. What's it called? The inspector?
Inspect element.
Yeah, inspect element feature. Where this down here is basically HTML code, and you can actually inspect these links, and it'll give you the URL to that link in here. So that's important to me because I actually wanted to go through and just scrape off as many lyrics as possible using these links. So I used the Jizza, Drake, and Wiz Khalifa. And the way I did that was actually not even using NLTK. I just used this code right here. So usually it's a port to show code on screen, but I thought this was short enough that I don't know if you guys can see that, whatnot.
Set background equals dark.
Yeah, there's no comments at all. Sorry, I did this last night. So the main thing that I use here is this terrific framework called Beautiful Soup. I don't know, has anyone used it? I see a couple people. Beautiful Soup basically takes any HTML text, and the first thing to do is beautify it so you can actually see it in a clean manner, and you can actually parse through it and determine, oh, there's a link here, there's an image here, and you can grab anything you want. So what I did is I grabbed the HTML that I showed you on the previous page, grabbed the links, and went to each link and grabbed the lyrics. So I actually didn't show you any lyrics yet, but let's say I go to one of these pages. So here's the lyrics right here, and if I inspect this element, it's sitting in here in this div which says class lyrics. So right here I found any div with class lyrics. So this tool helped me just grab a bunch of data and just organize it nice and cleanly. So is there any questions on this aspect? Okay. So now that I have the data, what am I going to do with it? Well, there is this, as I said, there's this toolkit called NLTK that allows you to use its classifiers that are built in, and you can use different pieces of text to determine classifiers. But in order to build a classifier, it goes out every second or so. It's an intermission. In order to build a classifier, you have to create classifications, two or three classes. So in this case, I had 3 rappers, so I'm going to classify Drake, Wiz Khalifa, and the Jizza. So what I did is I have this folder here called Rap, and in here I have each folder with each of their lyrics. So if I do this, I got about 178 songs from Drake, and yeah, each of them I had about 100 and something. So it was a good amount of data that I got. Okay, so the idea here, to step back for a moment, because I feel like I'm kind of going around in different directions, is I need a bunch of text organized and classified in advance so that I can use that data to create a classifier, a machine learning classifier, to classify new text. Okay? So I mentioned here that this guy had written this thing called NLTK trainer. This piece of code is really nice because what this guy did is, Jacob Perkins, he created this package that allows you to build a classifier very quickly in one line. Like you don't have to sit down and organize the data and parse through it, and tokenize it, and do all this. It actually does almost all that for you. So I'll show you an example right now, and I'll work through how that can be done. So this is where we could just start right here. So I have this folder, the NLTK trainer folder, and then with that inside it, I have this Python script called train classifier. It's part of the package. And the only thing I'm passing in here is this wrap folder. Okay. Actually, I don't think that's going to work. Oh, yeah, it is. So it's going to present a bunch of information as it builds it. And right away, we see it's loading the wrap folder. There's 3 labels, or 3 classes, Drake, Jizz, and Wiz for Wiz Khalifa. And it has 500 pieces of training features, or training documents, you could call it. And it's going to use the same ones to test it, which just doesn't make any sense, but we'll talk about that in a second. And then it gives you kind of this accuracy score, but more importantly, what I think is important is these numerics right here, the F measure for each of these classes, which is basically a percentage of how good the classification is. Okay, so I'm going to give you a better example. And what I'm going to do here is I'm actually going to use a fraction of the data. I'm going to say, let's say 70% of the data as training data to train the classifier, and then the rest of it, 30%, is going to be the testing data. So this is a more accurate number, and these are actually really high numbers, and I'll explain why in a second. So we can see that, and to describe some of these numbers exactly, the precision, the recall, and the F measure. Precision, if I have a bunch of data I want to determine and say, oh, I believe these 10 pieces are Drake, right? And then 3 of them are Wiz Khalifa, but it turns out that I only picked, out of the 13, I only picked 8 was Drake, then, and I missed a couple, then the correct amount I got was 8 out of 10. Let's just say 8 out of 11. There was a total of 11 that I missed. That's my precision. The recall is if there's additional Drake ones that I missed, I got 8 out of the additional, so it'd be total of 16 if there was other ones that I'd missed that I classified in a different category. So that somewhat makes sense, precision and recall. And then the way you calculate F measure is using precision and recall. It's kind of like a weighted average of the two. So the reason that these two were high is because, so there's no questions so far? I feel like I'm speeding way fast.
Makes sense.
So it makes sense so far? All right. So
What's the goal of this?
The goal is, so what at the end of the day, it said dumping this classifier to this file. At the end of the day, this file right here is your classifier. You could take this file and put it in a different Python application, load it, and you can start bringing in rap lyrics and determining, is this Drake, is this Wiz Khalifa, is this Jizza? It doesn't have to be rap. It can be whatever the hell you want. You know, it could even be you're trying to determine between Cantonese and Mandarin, right? So you have organized data ready. Now, there are other ways to do that, but it's just an example. Or you have the writings of William Shakespeare and you have the writings of Herman Melville. Okay, and based on their writing styles or the language that they use, you might be able to determine who wrote what. Okay, so I know I didn't give like too deep of context, but this is the main idea. So And so the point of this piece of software is it just dumps this out and you're done. If you didn't write this, creating your own classifier, like to write just pickling in general is a pain in the ass. I don't know if anyone's done it with Python. Because you have to make sure it passes over correctly and all this stuff, and the binary stuff is all good. And then just taking a sentence and tokenizing it, that's kind of a feat in itself because you don't know which way to tokenize it. He handles all that for you. So, I don't remember where I was going. Oh, so I told you that there was basically roughly 500 training features. Oh.
So, question about precision versus recall.
Yeah.
So, say you have 5 Drake documents in a set of 100 documents.
Sure.
And you correctly identify all 5. You get a precision of 1.
Correct.
But your recall will be very, very low because there was not.
No, your position and recall will both be 1. It's your other categories will suffer. If you said there's 10 Drake, if I said there's 10 Drake documents when there's really 5, but I got all 5, it's I got all 5 in my guess. I also got all Drake documents, so the precision and recall will both be 1. It's the other guys will suffer. So for example, the JIZA, let's just say that there's 5 Drake documents and 5 JIZA documents out of 10. I said all 10 of them were Drake. Well, my position and my recall for JIZA would be 0, flat out.
For the sake of the recording, you might want to repeat the question.
Oh, the question was just a clarification on between precision and recall.
You still don't get recall.
All right, let me give it a more defined explanation. Let's say out of the 10, there are 5 and 5, Drake and JIZA. Okay, I picked out 4 correct Drake ones, but I picked one of the JIZA ones as a Drake one. So out of my 5 that I picked 4 out of 5. Okay, so out of my own selections, I picked 4 out of 5 correctly out of Drake. Okay, but I happen to also miss one. It just happens to be that position and recall would both be the same for those numbers. Let me use a better number instead of 5 and 5. Let's step away from language processing. Think that I have a machine that's trying to identify dogs and cats in photos. Okay, I have 20 photos. 11 of them are dogs. 9 of them are cats. It identifies 8 of them. It identified and said, I found 10 dogs. Well, we know that first leader is 11, so it did miss 1 right off the bat. But let's say it did identified out of the 10, it identified 8 dogs and 2 cats. But 2 of the cats were dogs. Picked them as dogs. So right away, 8 out of the 10 were correct. So that's my precision, 80%. But I missed 3 dogs. So I'm actually 8 out of 11 on recall. There were 11 total dogs. I identified 8 of them. So the recall is 8 out of 11. I actually thought about making like a jQuery.
Like a true positive.
Yes, it's like false positives, false negatives, true positives, and true negatives. So that's effectively what will help you determine true positives and true negatives and so on. So yeah, sorry, I didn't. I actually wanted to make like a jQuery thing with a bunch of cats and dogs on it, and assume that it was, oh, these are dogs. And by clicking on it, you can kind of group them and see the categories. It's a lot easier to see statistics in visual ways, with marbles and red balls and green balls. So I screwed the pooch on that one. Okay, so I wanted to kind of explain why these numbers are actually high, because there's an option here called instances, and the one I'm doing right now is I believe it's files. So the numbers should come up the same. This option here for files should be roughly 97.2, 97.2, and so on. So what I did here is each file, each piece of lyric or whole song of lyrics is a feature. So the way I don't really want to get into how naive Bayes works or how these things work, but just imagine you have a full file, and out of it, this will help you determine if a new file coming in is a Drake song, is a whiz song or is a jizza song. Okay? So when you have a whole file to determine and match and see are words similar, that gives you a higher probability of correctness. But if I do this, instead of doing a file, I do a paragraph. Okay? My scores will suffer. You can see that I have more training features here. I have 2,200 training features and almost 1,000 testing features because it broke the lyrics up into paragraphs. Because in lyrics there's a lot of spaces in there. So you can see it immediately suffering. And that's because I don't have a full document, a full song to compare with another song. I only have paragraphs. So paragraphs sometimes don't indicate a lot. Or sometimes it might just have a chorus in there which might be like 6 words. So it's not as precise. And I can even break it down farther where I could do sentences.
Have you thought about like essentially n-grams for paragraphs?
Well, yeah, I was going to get into that next, yeah. It's... have I thought about n-grams in this situation for paragraphs? Yeah, you can get into unigrams, bigrams, and I'll do that right here. I'll see if the n-grams, is there... So if I do n-grams 1, that's just unigrams, it's regular. But if I do n-grams 1, 2, it'll do 1 and 2. So the questions about n-grams, which are basically, if I give you a sentence to determine its classification, a lot of times I'll just parse through one word at a time. Okay? Let's say I want to determine if a sentence has positive sentiment or it's negative sentiment. So I want to classify it as a positive or negative statement. A lot of times you look at each word individually. Well, what happens when you have, I'm not happy? Right? A lot of classifiers will see the happy and go, oh, this is positive. But if you use a bigram method, you'll see the not happy, and if it's seen it before in a negatively classified document, it'll know not happy has a higher correlation with being negative. So that's why you'd use bigrams, and in some situations, trigrams and quadgrams and 5grams. Google has this huge database of I don't know, tons of things they scraped off the web of all the way up to 5 grams that you can, I don't know if you can download it or if you can pay for like 20 gigabyte disk or whatever it is. It was a little bit much for me to deal with, but Drake lyrics are good enough for me for now. I guess I didn't even show you the format of a Drake lyric, but so, it's simply like this, just lyrics. It just, it's just pieced apart like that. So there's other classifiers. So the one I've been using is a naive Bayes classifier, which uses basically a Bayesian probability to determine what class it belongs to, whether it's Drake, the Jizza, or Wiz Khalifa. So another classifier I can use is this linear SVC, which is basically a support vector machine. Okay? And I'm not going to go into the details of it, but support vector machines can give you a more optimal result. And sometimes, actually, in this case, I use this package called Scikitlearn, or SKlearn for short. And it in itself is a machine learning class that Python uses that you can use by itself. You don't have to use the NLTK. So you can use it to do machine learning on things that are not natural language. It could be images, it could be numerics, it could be whatever it may be. And in this case, I don't have something to compare this with.
What was that called again?
Scikitlearn, like as in science, or SKlearn. In order to use it, you have to install NumPy, the numerical Python library, and then SciPy, the scientific Python library. Which the instructions on how to do that are right here. You need these. I highly recommend it, especially if you want to install from source. I recommend it because you'll get a speed up if you have a better processor in your machine. If you have some sort of Xeon or i7, it'll this Open Blast library, which does a lot of linear algebra for you. can't read any of that. It'll exploit some of the things in your processor. So I'll put these links somewhere. I don't know, maybe on the Python page. So if you guys want these, the GitHub username for this is SNIDERBR. So Snyder BR. If you want to look them up. If you don't trust me, then I'm going to post it later. So yeah, these are full instructions on how to install NumPy, SciPy, and so on, and the OpenBlast library. OpenBlast has become kind of the new standard for open source linear algebra computational stuff. It's a C code, so it takes care of it for you.
How long are you planning to have your pickles stay around?
What do you mean?
No, you're dumping this all to a pickle.
Right.
And I'm wondering how long you're expecting it to stay around. And the reason why I'm asking is because I know that I mean, if it's fairly ephemeral, it's not a problem. But I think pickles are not like if you go from one version of Python to the next. I don't think they're preserved. I don't think the pickle language is preserved.
Yeah, you're right about the ephemeral nature of it. Because I'm gonna create a classifier, and I'm just gonna dump it right away to something that I need to use it for. That's kind of the main reason I have this. So if all of a sudden I upgraded my Python, I'm just going to create a new classifier. I'm not going to really...
so it's not storage, it's just the communication.
Basically, it's like a short-term storage so that in case, for example, you reboot your server, right? The way I do my natural language processing, I have a REST server that just kind of is waiting for any communication to it. So if I get a sentence or I get something, it's got the classifier already loaded in memory. But what happens if it reboots? Well, it's a good thing I have it pickled, and it'll read it back up when it boots up again. Okay. So that's kind of the main reason.
I presume. Okay.
And secondly, I have no idea much about pickles, so I like pickles, but beyond this, I just know that it's a good way to store data. Python has made it easier. So I'll be the first to admit that I'm not an expert at pickles and storage and long-term storage, but just to answer it, it is a short-term thing. Yeah, so any questions about classifiers?
Probably, and maybe revealing my ignorance about just Python structure. When you're choosing a fraction, I mean, is it choosing the same fraction of files each time, or is it different?
So I had the fraction like that last example was 0.8, so it just takes 80%. That's a good question. I don't know if it does it randomly or not every time.
Right.
I don't think it does. I'm pretty sure it doesn't because we saw a second ago that like the percentages
It seems to have the same returns each time.
Yeah, so I don't think it's random every time. You might be able to seed it with a new seed number to get it going. But yeah.
Yeah, just to clarify, the classifier that you're building is dependent on, its behavior is dependent on all of the data sources that you give it. So if you took out Wiz, the behavior of how it classified Drake and Jizza would be different.
Very much.
Right, rather than when Wiz is in there. Right?
Exactly.
So its behavior of how it would classify them would be completely different.
Exactly.
It's only within the context of everything that you give it, right?
Exactly. So just to reiterate for the recording, anytime you have a classifier, you're determining right there and then what classifications to do. I mean, it's not so generic where you can say, oh, well, let's drop one of them, because you already hard-coded it in there. So anytime you determine 3 classes or 4 classes or 2 classes, it's fixed. So
Just when you're playing around with this, do you ever feed in thing? Yeah, well, feed Shakespeare into your rap thing. See what it comes up as.
I did this last night. I was like, oh, I gotta pick something. So by all means, you can do it, and let us know next time. That leads me into something that I did want to show. So NLTK, as I said, is a full package. But in addition to being a package, You can also download a bunch of corpora, like you said, Shakespeare XML corpus sample, C-SPAN State of the Union address corpus if you really want to go to sleep. Something I will get into in a second, Penn Tree Bank sample. You know, they just have a lot of things in here, and so on. So
the thing is that you have to remember what you put into it is mostly dictated by what you're trying to find.
Yeah.
So they use Bayesian classifiers for spam, right? So how do you train spam? You give it spam.
Yeah. So like with spam, for example, actually, I learned that because 80 or 90% of the email on the internet is spam, you have to have that much data into the classifier. Otherwise, you're going to screw up your data if you make it 50-50. You're going to screw up your classifier, and you're going to have somewhere closer to 50-50 choosing that it's not spam, and you don't want that. Now, that's not like a hard rule, but it happens to be for that reason.
So you would never have like an other category?
You could. I mean, yeah, you absolutely could.
Like a specifically not defined category.
But you have to train it and tell it that I'm going to put, I don't know, Kanye West in there. I'm going to put everything else in there. And it would make sense to put all those other rappers in there. If you know you're going to get all those rappers, right, you need to put all those rappers in there because you got to make sure that you're covering all your bases as best as you can.
So, well, I think maybe this is another way of rephrasing what was just asked, but if the classifier is unable to classify something, okay?
It will classify it. Yeah. Wrongly.
Okay, so does it always classify, or does it say, I can't tell the difference between these three guys, or does it say it's none of these three guys?
The best at giving up is it'll give you a probability it's exactly half and half or something. Let's just say it's a binary classifier of two things. It'll give you exactly half and half, and by that it'll just say, anytime I have half and half, choose the first one. So that's the only time it could give up, but you won't really know that. Most of the time, I mean, sometimes you'll get the probabilities, but you're not really interested. At the end of the day, you just want to get a whole.
So it can't give you another. It can't say other. There's no point in another.
Unless you train it.
It doesn't know.
Right. So because other would be the logical.
If you had a very large
not
bucket of other,
right,
then it would be able to identify potentially other things that look like those other things.
Right. But it's not the logical. Not any of these classes.
Yeah.
Trained on.
You could put Shakespeare into what you have here, and it
You
would
could
tell you
filter by,
which
like,
thing it
score
was most
and
like.
someone was less
Right.
like.
Yeah.
You find out which rapper was.
Yeah, you could actually probably. So
You could
you
feed
could
it all
say.
kinds of random stuff and say what
What
it
rapper
was
is
most
Shakespeare
like.
closest to?
And then you can also. So an interesting point was brought up is that I could feed Shakespeare in here to see which rappers end up most like, right? Or reverse it and make classifiers for Shakespeare and all the different writers, you know, whoever you care for, and then put the rappers in there. You go, who's this rapper most similar to? So you can have a field day with it in that way if it's just for pet projects. Most of the time, I feel like work-related projects don't really care about these fun
You're not going to get the
ideas.
scores, you just want to get lots of stuff done.
Yeah, but I mean, I guess the fun stuff was to determine if it looks like Shakespeare or not. I don't think any corporation really cares if Drake's lyrics look like Shakespeare or something.
Some of the best authorship attribution algorithms are actually just character n-grams or stuff. So you just give it a bunch of data and you break it up into characters, and then you train a class like a 10-gram model on that, and then you compare it, and it turns out it's really good.
Do you know who's built that, or it's just?
He's got an unpronounceable name that starts with a K. I can try looking it up if there's one.
No biggie, but is it a Python thing or is it just?
No, it's like just a paper. So they
Yeah.
an algorithm. I don't know what the implementation.
Yeah, there's a lot of papers out there that just say kind of like sometimes you don't need to build a classifier. Sometimes if you just look at a keyword in there, that's good enough for some sort of classification. If you have some sort of idea, it always comes down to this basic idea that they say like you don't have to get down. Actually, this is what I've heard about Google. We don't have the best algorithm, but we have the most data. So, you know, that usually is indicative of what the preference is, I guess you could say. I have just one more thing, but it's not classifier related. So You had have any more? Okay, 5 more. Oh, okay. Yeah, this will take like 30 seconds. But any other classification related?
So you showed us 2 classifiers. Maybe there was a 3rd one in there.
Oh,
How many are in the package? I assume there's a ton of different ones.
There's actually, if I screw this up, it'll just give it to you. So these are all the options for NLTK Trainer. These right here are all the options for the different classifiers. Naive Bayes is a default. You can do decision trees, maximum entropy, a bunch of these acronyms I don't really know. Mega M, which is actually a maximum entropy classifier built in OCaml. And I actually got it working, believe it or not. It took me a while of compiling an OCaml code to get this thing going. And it's pretty fast, actually. And then we hit the Scikitlearn, and they have their own similar classifiers, such as gradient boosting classifier, Gaussian, random forest classifiers, which are somewhat popular, but I haven't really studied them a whole lot. Like I said, the one I would use personally is the SKlearn multinomial naive Bayes NB, and the SKlearn linear SVC, cuts off here to here. They also are the least memory intensive. So using just a generic naive Bayes, it was taking up like 3 gigs of RAM or something for some. I only had like maybe 100,000 pieces of features, and then after using this, it dropped down to like 300. So huge, like tenfold decrease in memory, and that was just amazing. So I can have multiple classifiers loaded into memory. I don't have to use just one. I can maybe have several to do different types of classifications, if that makes sense. Yeah, so I was just saying about the tokenizer. You do word tokenizers, sentence tokenizers, paragraph block readers, the n-grams. You know, it's just so much available that I just don't really have a lot of time to get into.
Besides memory, why would you want to use one classifier over another?
So that's a very good question. So for example, like between naive Bayes and linear SVC, or just support vector machines, they're completely 2 opposite ways of operating. Naive Bayes is a pure probabilistic, count how many words are in this document, and basically guess this new document that's coming in, guess what classification it's in. Support vector machines, basically a better example that's not text associated, but somehow you can, if you can map this idea to text, just imagine you had the weights and heights of people, and you plotted them in a thing, and you were able to determine male and female from them because you could basically draw a line, generally, right? Generally speaking, as to who's a male and female. Once you draw that line, you can determine any new pieces of content, whether that person is a male or a female. An appropriate guess. Imagine that. That's a support vector machine, basically. Imagine that in language, being able to map a new sentence or sentences based on their features, which are basically dimensions. Does that make somewhat of a sense?
Right, like where the words, the type of words, and what's much more likely to follow one word.
Yeah.
This is a sentence versus this sentence is.
Yeah, like let's say I have a sentence, right? Each word in a sentence can be mapped along some dimensional axis. And then all of a sudden you see a clustering of Drake's lyrics are kind of clustered near one area, and then Jizz's lyrics are clustered in another area. So you can see that there's a clear line separating them. That clear line, not just a line, but it could be a plane, could be anything. And when you have and then you can create this some optimal distance between the two, depending on what side that your new piece of data will lie. That's the classification.
What sort of access would these words be? How would you?
I actually don't know.
Oh, okay.
It's more of the fact that each one would just be. It doesn't have some sort of true value, true meaning. You could just apply some sort of weight to it, some sort of score to it. If that makes some sort of sense. I'm gonna quickly do this last thing, which let's see. Just jump into Python, import NLTK, and I'm going to have a sentence, you know, actually do. So I actually want to tokenize a sentence beforehand. Tokenizing just means break it apart into an array of words, or a list of words. And the reason I want to do that is because I want to do NLTK. I have a terrible memory. I always look up on the same question on Stack Overflow probably 15 times. And I'm like, wait, I started and I upvoted it already. Well, how do I not remember this? And so this, for example, is a POS is part of speech tagging. So I is a proper noun. Like is a past tense verb. Brown, I don't know what RP stands for, but shoes is a plural noun. So these, you're not used to seeing these types of part of speech tags. These are called the pen POS tags. And they're all explained right here. And this, I think, is actually really, really useful. I can get into why, but just if you know the verbs, if you know the structure of a sentence, and you know that some sentences that come out angry or that come out, objective or subjective or whatever it may be, have a certain structure behind them, you could start just using the part of speech structure to determine that, and that'll help you determine any future sentences that come in if you've done your analysis. Like if you know that you run some customer service email center and 90% of emails of people are angry have a past tense verb, let's just say, right, in there, then you could use that to determine any new email is coming in as a potential, like to flag it for angry customer, right? I'll just say it's using part of speech. There's a paper out there that's very good at determining whether it's objective or subjective. So, any other questions?
So could you flip back to the editor for a moment?
Yeah.
What did RP stand? What did
RP particle.
Should be an adjective.
Yeah, sometimes it misses it. I mean, it's not perfect, as we can see, but it's pretty good. It's pretty amazing how good it is. Usually if it doesn't know what it is, it just labels it as a noun. Like, I could put just gibberish in here, it'll just be like noun, 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 noun. Any other questions?
Did when you parsed the text, did you chunk it too for the classification?
For the classifier?
Yeah.
Yeah, I told it to chunk it using that instances. There it is. Instances. You can tell it to chunk it in sentences, paragraphs, or files.
Oh, okay. Sorry. No, I was thinking about
tokenization.
Yeah, chunking tokens. Like getting noun phrases and things like that.
Yeah. Oh, the part of speech. Mm-hmm. I didn't do that at all in the classification. You could make that some sort of like you get some document. You can do it beforehand, and then maybe do something with that. Mm-hmm. Maybe you can feed that into a classifier. You're better off leaving that text as is. Create and use the classifier in that way. And use the part of speech to determine any other, like if you need a confidence interval to say, oh, this is definitely whatever it is. So you can use it side by side. I would use that approach rather than saying, let me just give it the part of speech and see if we can determine using that type of classification. I mean, you could also build two classifiers, one based on a part of speech and one based on the actual text. So.
Yeah, I can't think of a good example, but what I was thinking about was whether the classifier would be smarter if you were able to teach it that, this chunk, this noun phrase right here is one thing. So I'm talking about that one thing as opposed to talking about the individual words around it.
Look for nouns. Like to tell it to look for nouns
Well,
and then to do something?
not
Or?
necessarily just nouns, but like it happens on other. There's other phrases that happens.
New York.
Yeah, exactly. Things like that. Well, named entities would be another thing too.
Well,
It picks up named entities
Okay.
pretty well, the part of speech type, usually. If you use the right one, the generic one that is built in. So you not only can build your own based on classifiers, but you can also use ones that are available and you can pickle them and then use them later, which also are faster and have better memory consumption and so on, using different algorithms and so on.
well, thank you. We can continue this conversation afterwards at the bar. Thank you very much.